So distance is any length between 2 points. Distance symbol is d, and SI units are meters. Displacement is shortest length between 2 points in a straight line or specific direction, if you want to say that. The symbol for displacement is S, and the SI units are meters. Now, what is the difference between them? The main difference is that this is a scalar quantity and this is a vector quantity. All right, is it clear, everyone?
Yes.
Okay, good. Now, both Khatijas are not here. Interesting. Anyway, now for the very first question that shows a ball travels from X to Y around a semicircular block, which has a radius of 1. It says, what is the displacement of the ball from X to Y? So now X to Y means that this is the radius, which means it will go here and then it will continue to go here, which means this is 1.0, this is also 1.0. So you get 2 meters, and because it needs to have a direction, so it's towards the south, so it has to be B, 2 meters due south. All right. Okay, Hamad. If you look at this, you see displacement has to be in a straight line. So wait a second, please. So basically what it means is it will go down and so this is the radius is 1, and to reach Y, it has to go straight again. So this is also 1, so it will be 2. Don't you think so? Hello?
Yes.
Walaikum salam. जी जी Okay, now, so then we need to learn about speed and velocity. Speed is basically, even if you write distance over time as a formula in your, if they ask you this, so that's actually fine. They won't say anything about it. The symbol we use for speed is S, and the SI units are meters per second. And the thing is that it's a scalar quantity, whereas for velocity, you can write displacement over time. But the thing is, you have to write the full word. If you write, like, for example, velocity is equal to displacement over time, they would not understand that. So you have to write the full words if you want to, write the formula in the definition. The symbol is V. The SI units are meters per second, and it's a vector quantity. You need to remember that. Now, So generally, for example, it says an object accelerates in a direction that is always perpendicular to the motion, right? So it's talking about like a circular motion, which means that if something is moving in a circle, that's the only way when the acceleration is towards the center and the velocity keeps on changing. Is that clear, everyone?
Yes.
So what happens is it says, what is the effect? Obviously, the value, the magnitude doesn't change, which means that speed has to be constant. But then direction is changing every time because of the acceleration. So it means that it has to be changing. So C should be the right answer because every single position, because of the acceleration, whether the value of the velocity is not changing, but the direction it changes. That's why velocity is a vector quantity. Okay, if you have any questions, please let me know. Ayan, how are you?
Good. So how are you?
I'm good. Okay,
Yeah.
so then going to the next part where this is
Sir,
another.
wait, if it says
Hmm.
in always in perpendicular direction, how could the direction
Uh,
change?
It's always perpendicular because it's going in the circular motion, so it's always 90 degrees, and acceleration is towards the center. That's why.
Okay.
Now, only in circular motion this is possible. Otherwise, it is not possible, right? Only in circular motion that the acceleration is perpendicular. All right, is that clear?
Sir,
Yes, I will.
if instead of speed, velocity would be written, then it would change?
Yes, obviously, because uh, the direction is changing. That's why.
Okay.
Now, so now in this question, it says the diagram shows a velocity time graph for the mass moving up or down on the end of the string. Which point represents the velocity of mass when it is at lowest point of its motion, right? Now, if you basically look at this question, it's a wave, and the wave shows that every single time the velocity is of a different value, right? All right. So, which means that, which basically means that this changes with respect to, points A and B. Now, the lowest point of its motion could be a couple of things that we need to remember. First of all, if you realize these points, at this point, it has the maximum velocity. And here as well, the velocity is the highest, right? But it is in the negative direction. Do you guys understand this?
Yes.
So obviously, the lowest point of the velocity would not be A, would not be C. Now we need to see what happens to B and D then. So if it's B and D, then imagine this, right? If this wave goes a bit forward like this, what do you expect B to go? Where do you expect B to go? B will actually go upwards. Do you guys understand this?
Yes.
And
I
D would basically go downwards. Yes. Yes, Anne.
nothing, sir. Sorry. Yeah.
Do you understand what I'm saying? If the wave in the next second moves this much, then B is going to go up. So it's going towards the highest. Now, right now, it is at the highest point of the velocity, like it's going towards the high point. And D is going towards the low point, which means that D's direction is going towards negative, which means that this has to be the lowest point at which it could be. So that the answer is D. So lowest point, because after this, it will be negative. Do you guys understand this? All right, Aman and Aiza. And Aiza, you Javeria, right? Who's Aiza? I don't know.
Yes, sorry, sir. It's
Okay.
really.
All right, your sister. Okay. And Ali, Khatija, that's very bad. Late. And Yaya, okay.
I-
And
I'm a little bit
Ryan,
confused.
okay.
Sir, can
All
you
right.
explain again?
Okay,
Yeah.
sure. So you do understand that right now in the question, it says that the mass is moving up and down on the string. And now we want to find when mass is at its lowest point of its motion. Do you agree? A is at the highest point, which means that it is positive velocity here and the maximum one. Agreed? So A cannot be the answer. Neither C, because C is at the maximum velocity, but in the negative value. Understood? Do you understand my point? Now, think about it now. B, if the wave travels like slightly forward, what's going to happen is that B will travel upwards towards being positive and maximum. You agree?
Yes.
And D needs to go down, like the point D will come here, right here, which is basically going down means right now these 2 points at zero velocity. But now this is going to get bigger in the sense that it's going to get positive, and this is going to get smaller because it is going to get negative. That is the reason that the lowest point I selected as D, since D is the point where it will become negative and it is going down. Do you understand this?
Yeah.
Any questions now? Yaya, do you understand now?
Yes.
Very good, very good, excellent. Now, next question. This question is super easy. All you need to do is you just need to remember this particular thing. If they give you, if they give you um, change in, oh, in fact, let's write difference in velocity of two objects, okay? Like difference in velocity between two objects, then either they will give difference in distance or time, and they will ask you to find the other. Like for example, in this one, if you check the difference between x and y is basically 30 minus 20, which is 10 meters per second. Do you guys understand this?
Yes.
And they have given the difference in the distance between them, which is basically 50. So now they say, what is the value when t is level with y? So they want to know what will be the difference. How much time will it take to cover up this difference with this much velocity, right? So what you're going to do is you simply use velocity is equal to distance over time. And now because you want to find the difference in time, so you have to use the same differences, like distance would be 50 and divided by 10. So it's going to be 5 seconds, and that would be the answer. So that's super easy. Otherwise, you would have to, use so many equations to prove that, okay, it's one is going at 30, how much time it will take to go to 50 meters. And for that, how much time will it, how much distance more 20 will cover within the same time. So that would be too long. So that's just a tip to remember that this is how it's going to be. All right. Is that clear?
Yes.
Okay. Fatija, which Fatija are you? Irfan or the other one? Dubai one?
The other one.
Okay. Dubai one. Okay. It means Khadija Irfan is not here. Anyway, now most of the questions that do trouble us are from the average speed. Now, average speed is very simple. All you need to do is you need to find the total distance traveled over total time taken. Now, obviously, average speed needs you need to remember that this time taken must also include the time of rest or stop. All right. So it means you're taking a break or you're like moving from one point to like you're resting or you're having coffee or you're chilling, whatever you're doing. It means that particular time will also be included in this. The other things are very simple. You just need to remember the symbol of average speed is the same, and the SI units would be the same, meters per second. And obviously it is a scalar quantity as it is a speed. Now, so let's look at this particular question from average speed. All right. So for the very first question says, a person traveling on motorway, a total distance of 200 kilometers, travels the first 90 kilometers at an average speed of this, right? Now, I should always remember that the wrong thing that most of the students do is that take they take velocity 1, they take velocity 2, and then divide by 2. This will give you a wrong answer. So please do not do this at all. Absolutely no. Now, what you're going to do is you have the distance and total distance in 90 kilometers. What is the average speed must be obtained for the rest of the journey if the person needs to reach destination in 2 hours, right? So first of all, I need to understand that I have the total distance already given to me, which is 200. Out of that 200, I have already covered. So the net distance that is left is basically 200 minus 90. So I got to basically travel 110 kilometers right now. Okay. Then if he needed to travel in 2 hours total, which means now I need to find how much time he has spent in traveling 90 kilometers. So now what I'm going to do is I'm going to say time is equal to distance over velocity. Distance is 90 and velocity is 80. So this basically means that 90 divided by 80, uh-oh, this is going to be 1.125. Hold on, please. This is the last time. No. I really need to stop this syncing. Let me just try and stop it somehow. Sync, auto sync. No, wait. I know. Would stop syncing. Anyway, chalo chodo. Let's do it later. So it is 1.125 hours that basically he has or she has already used. So now you need to remember that the net time left to cover up this distance is you got to subtract this value from 2 hours. So 2 minus answer. So he or she got only 0.875. Zero point. Okay. All right. So it's going to be 0.875, right? Hours. Now, speaking of this, then, now we have this. Now, simply what you're going to do is you want to find the average speed. You will divide the distance remaining with the time remaining. So could somebody please help me with this? Otherwise, it's going to just go in syncing again. I think it should be like around 120.
125.7.
It should
Okay,
be
that's 126. All right, good enough. All right, do you guys understand what I've done? Any questions, please? Sohail, Ryan, Ali,
No,
Wassam,
sir.
Mar, and Pluto, and Khatija, Dania. Dania, why you never speak? Okay, and Aman, Ayan, Ahmed. All right. Now, this question.
Sir,
Yes,
how did
yes,
you
Ahmed.
get 0.875
So
hours?
basically, what I did was, Ahmad, the remaining time that basically the total time I need to reach the destination is 2 hours, right? So the remaining time would be 2 minus 1.125. That's how I got 0.875 hours left. Do you understand?
Yeah. Okay.
Now, I simply love this question, and this is so important to understand because the most common mistake that I was basically talking to you about, this one basically tells you about that. For example, if you look at this question, it says an aeroplane travels at an average speed of 600 an outward flight, which means from destination A to destination B, it goes like this and at 600 kilometers per hour. Then it says and 400 on the return flight. Return flight means that it comes back to the same destination with 400 kilometers per hour. Now it says what is the average speed? Now most of the people would do 600 plus 400 and they were going to divide 2. That will lead us to 500 kilometers per hour, which is an absolutely wrong answer. So please do not attempt this. Okay. Now, what you're going to do is, first of all, assume that the distance it needs to travel from A to B is S. And when it comes back, it also travels S. So the total distance that you got is basically 2S. Now you need to find the total time, right? So first of all, we are going to talk about the outward flight. Okay, so for the outward flight, I'm going to say it's going to be, what do we need? Time. Time is distance, which is S divided by the speed, which is 600. Okay, so this is the time for the outward flight. And for inward flight, the time is going to
So
be,
what the pace SO 400 outward is 400, right?
no, it's 600.
Oh, okay, okay.
400 is the return one. So S over 400 is going to be the return flight. Okay, let's call this T2. Now, what you're going to do is you're going to find the total time. Total time is when we add the time together, so 600 plus S over 400. Now, most of the people would be, thinking that how would we solve this? It's pretty simple. S is just the same thing. So you use your calculator, you write 1 upon 600 plus 1 upon 400. And that's going to give you something like 1 upon 240, right? 1 upon 240 means that it's going to be S over 240 because S is the common thing, right? So now what I get is I get S over 240 as the time. Now what you're going to do is simply just use average speed formula. The speed equals to the total distance was 2S because it goes and comes back divided by S over 240. Now, as you can see, S and S is going to cancel out and 240 is going to multiply on top, leaving you with 2 times 240, which is basically 480 kilometers per hour. So that's the answer, not this one. Understood?
yes.
Okay, please have a look at it for once and let me know if you still have any confusions. And please be very mindful that you need to find total distance, total time, and then only you can find average speed. You cannot take mean of it like you do in maths. That would be wrong. And you still don't do it in maths. Okay. All right. Now, let's go to the next thing. So, acceleration is called, there are two possible definitions. Okay. So, first definition is that you write rate of change of velocity. This is a standalone definition that is complete, or you can write change in velocity per unit time. Now, what people do is, which is basically an absolutely wrong definition, so do not write this wrong definition. And they say it is the rate of change of velocity, and then they say per unit time. Writing per unit time again basically means that you're now dividing time twice, because rate of change already means that you have divided by time. So please do not make this mistake. Acceleration is given as v minus u over t, where obviously this is the final velocity, this is the initial velocity, this is time. And just to tell you that a negative value means deceleration. And in short, if I want to know what deceleration is, it is basically decrease in velocity per unit time. So it means every second the velocity is going to decrease by whatever value you find. All right. Any questions, please let me know. Okay. I should have left a little bit more space. But anyway. Okay. Okay. Ahmed, Aman, Ayan, Dania, Javeria, Khatija. You guys understand this? Everything is clear up till now?
Yes, sir. Yes.
Also.
Okay. Laiba, Ali, Ryan, Sohail, Hamad, Umar,
Yes, sir.
and Wasam, Ahmed, Yaya, and Zahan. Everything is clear?
Yes, sir.
Yeah.
Yes.
Very good. Very good. Excellent. Now, we're going to move towards the next part, which is basically the derivation of certain equations. And wait a second, please. I need to sort few things out. All right, now going to the first equation. So first of all, the graph that you see right here, it's not required if you just rote learn it, but it's a helping thing that you should, draw. So the graph starts from initial velocity, it ends at final velocity, and there is time, as you see. The first equation is pretty simple. All you need to do is you know that acceleration is velocity v minus u over t, and if you multiply t on at a, so it's going to be at v minus u, and because we need v as the subject, you can take u on the other side, so it's going to be positive, and that's the first equation that you're gonna derive. There are very slim chances that they're going to ever ask you for this. So we'll move to the other equation. The other equation is that, first of all, you guys should understand that this shape that you see is a trapezium. Now, the formula for trapezium is that you need to have two parallel sides. So you have one parallel side here, one parallel side here. So one is u, as you can see, and the other side is v. And the height of the this trapezium is t. So area under velocity time graph always gives you displacement, and then the displacement is going to be half times t, which is the height, times sum of parallel sides, which is u plus v. So now what you can do is you can write it as u plus v times t divided by 2. And let's keep this equation. This is a general equation for trapezium, so we don't have to worry about it. They're not going to ask you directly for this. Anyway, now speaking of this then, what you're going to do is, if you realize that here you have the equation for velocity, and what we can do is we can write here, we can put it right here. Okay, so if I do that, then displacement will be equal to u plus at. So I just replaced v with u plus at times t divided by 2. Now what you're going to do is just simplify this. So it's going to be u plus at, and then we have time, and this is 2. This is going to be 2u plus at, and then time t divided by 2. Multiply t inside, so it's going to be 2ut plus at squared over 2. Now what you need to do is, um, 2 gets divided on both terms, so you can write it as 2ut divided by 2 plus at by 2. So 2 and 2 will cancel out. Ultimately, it will leave you with ut plus half at squared, and that's the second equation we
So
need
do you
to.
have to remember the derivation?
Yes, you have to. This might come as 2 mark only, but yeah. So well, this isn't very difficult if you remember the first equation, right?
Yes.
Now, the third derivation is rather, it is the most complicated amongst all of these. First of all, let's write the equation for acceleration, which is this. Now, if I make t the subject, then it's going to be t equals to v minus u over a, like that. Okay. And then what I'm going to do is I'm going to put this t right here. Okay, so this is the primary equation that I written in blue. Okay, so what you're going to do is now s is equal to v plus u over 2. And instead of time, I'm going to multiply v minus u over a, because I've replaced this time with this time. Do you guys understand this?
Yes, sir.
Yes.
Now, if you notice something very interesting, which is u plus v is being multiplied by v minus u over 2a. The top function that you see represents a function of math, which is a plus b when multiplied by a minus b gives you a square minus b square. Who doesn't know this? So that's a math identity. And then obviously we can we can write the above thing as S equals to V square minus U square divided by 2A. You multiply this on the other side. So it's going to be 2AS equals to V square minus U square. And that's the third derivation that you need to remember. Understood?
Yes, sir.
Please have a look at it. Let me know if you have a question. Javeria and Wasam, Ahmad, Ayan, Tanya,
No, sir.
Ryan, and Yaya. Everything is clear?
So we have to memorize this all.
Sorry, come again?
I'm saying, do we have to memorize this all?
Yeah, or just learn how I've done it. This is a requirement, unfortunately, right? So both the second and the third derivation might come for 2 marks. The first one, I've never seen a question about it, so but it is required in all both of them. So yeah, you need to revise everything. Okay. Now, about these 3 equations of motion, the 2 things that I would like to put forward here. So please note here that these equations are only, wait, only valid for number 1, objects at constant acceleration, and number 2, moving in a straight line. So you can't use it for circular motion or anything else, only when they're moving in a straight line and the value of acceleration is constant. All right. So in the questions, they will sometimes write uniform acceleration, which is the same word as constant. So it's a synonym. So you don't have to worry about that. All right. So just find this clue. And you should always remember that this is the equation we're going to use amongst these 3. Now, if you look at these equations very carefully, you might see that there are 5 basic quantities written. There is S, U, V, A, and T. So I call this SUVAC. S is the displacement. U is the initial velocity. V is the final velocity. A is the acceleration. And T is the time. And the whole kinematics is basically based on these 5 quantities, nothing else. Okay. Now, you guys have copied it? Should I go forward?
So let me just take a photo. Very quick. You can go for
2 minutes, sir.
Okay, sure. Okay.
Okay, sir.
Okay, all right. Now going to the next question. Okay. So in this question, it says an object has an initial velocity, a u, and an acceleration a. The object moves in a straight line. So this is the first clue. And then through a displacement s and a velocity v. The above quantities are related by this equation, as we already know this. Oh, by the way, these equations are already given in the exam. so you don't have to remember them, but it's a good thing to remember because you want to save some time. You don't want to, just flip pages back and forth. Anyway, which condition must be satisfied in order for this equation to apply? What do you guys think?
Constant acceleration
It needs to have a constant acceleration, right?
and should be in straight line, it already is.
Yeah, but there is no option like that. What else? A constant acceleration and the direction is also constant, which means the straight line is not changing, right? Yeah, see. Do you guys understand this? So please do remember this fact. Now going to the next one. Okay.
Sir, if
Now,
the magnitude is constant, or magnitude of A, which is acceleration, right? Okay, sir, I get it.
yeah, the acceleration. Yeah, obviously A. Only it works when it's A. Now, so question number 7, a car is traveling with uniform acceleration. The moment you read this, you should understand I'm going to use SUV-AT here. Along a straight road. So they've also given you the, the direction. The road has a marker post every 100 meters. When the car passes one post, it has a speed of 10 meters per second. When it passes the next one, it has a speed of 20. So it means between post A to post B, the distance is 100 meters. The initial velocity it had was 10, and the final velocity it has 20. And so, what is the car's acceleration? Now, how do we decide which equation are we going to use? So the best way is that you write SUVAT and fill up the list. So we got the displacement, which is 100 meters. We got the velocity, which is 10 initial. And then we have the final, which is meters per second. Acceleration we want to find. The time is not given. So which equation should we use then?
The third one.
The third one, which is basically
2AS is equal
2AS
to
equals. Exactly. So if you write this, basically this makes your decision easy, right? So that's your clue that which equation we're going to use. Otherwise, we're going to take some time. So A times 100, V is 20 squared minus 10 squared. Who can actually find A, please? Otherwise, it's going to go uh, into that loop. Okay.
so it's
Well,
1.5.
1.5. Excellent. All right. Very easy. Okay. So then it says an object falls 10 meters from rest before entering some water. Assuming air resistance negligible, what is the time taken to reach water speed with constant? Okay. Now, the thing about this is, again, I'm going to write SUVAT and I'm going to fill up the thing. So displacement is given as 10 meters. Initial velocity is 0 because it says it has fallen through rest. And then final velocity is what we need to find. Acceleration, when you fall under gravity, it has to be 9.81 meters per second squared. And then the time is not given. We also need to find this. So you need to use two equations, right? So first, if I want to find the final velocity, what do I do? Which equation, please?
Third.
Third
Third one.
equation.
Okay, so 2as equals to v square minus u square. Could you guys just quickly solve this and let me know the answer? And then also try to find the time one so we can move forward. So time should be the second one, right? S equals to ut plus half at squared. Could you please do this? All right. While you're doing this, I just wanted to tell you that the reason why I took 9.81 as positive because it's falling in the same direction as acceleration, right? So if it's falling in the same direction, you take it positive. It's not, you take it.
The speed is 40.0.
Yes, sir. It's 14.0.
Advancement. Okay, I'm listening on the. Okay, done. What is the answer then? What is the answer, please? Call that.
Sir, it's 1.43
And
for the
14.
time.
and 14.
0.0,
Okay,
yeah.
cool. All right. Yeah, very good. Now, this question is your homework because this is the very same question. Okay. And now, all right. So, yeah. And this question, we're going to basically continue tomorrow. So, make sure that you do this question so you are prepared for tomorrow. And I will see you
So tomorrow.
in the. Oh, no. Sorry, tomorrow, not tomorrow. On Monday then. All right. Okay. But if you practice, like, these questions, some of them are very similar, right? So there are a lot of questions. If you try to attempt some of them, it would be very nice. Should I give you some of them more? Wait. So you don't have to do 12. It is a difficult question. You don't have to do 9. It requires a bit of understanding. You can basically, no, not even 7. 7 needs to be done later. Okay, so you can do this one as homework. You can also do this one as homework. Very simple. And you also need to do this one as homework. And what else? Let me see if, okay, yeah. This question, okay, that's all you need to do as homework. Is that clear, everyone?
Yes, sir.
Yes.
Okay, so let me see why I haven't, why the PDF is not coming complete here. Should be complete. Wait, you copy it. Oh, okay, fine. All right. So I will see you then in the next class. Have a nice day. Bye.
Sir?
Yes.